Good day everyone. For today's video, we're going to make a video tutorial for installing the Proteus. First things first, we must at least meet this minimum system requirements. So for the CPU, we need of at least 1.8 gigahertz and with a RAM of about 3 gigabyte and with a graphic processing unit of Intel HD Graphics 3000 and has a operating system Windows from Windows XP, SP3 through OS X 10.6 and above. So for the storage, we have at least 100 MB HD space. So for a recommended system requirements for smooth and good graphics, we need of at least a CPU of 2.2 GHz dual core and of about 4 GB RAM with the graphics processing unit of about 512 MB NVIDIA or ATI graphics cards. For OS, we need to have at least Windows XP, SP3, OS X 10.6 and above. So for the storage, so we need also a 100 MB. So next, we need to download it from the site.
So today I'll be showing and discussing to you how to download and install the software application called Proteus version 8.10. So we provided the link of this installer in the description box. So as you click the link, this will show, and then just click this file and then download. Then just wait for it to be downloaded. So after downloading the installer, we have to extract the file. So just click this and then extract file. So I will extract the file here in folder named Proteus. Then in the link that we provided, the password is included there. So the password is 123. Just type and then click OK. Then wait for it to be extracted. And then after that, proceed to the folder that the extracted file located. So just click this and run this application as administrator. Then click yes. And then this will pop up. You can also select a different folder. So just click this browse and then you can select other folder. But I will choose this file location. So next, you can also select a different folder. Then next, then wait for it to be installed. Then click finish. And then as you can see, there is already a application here in our desktop, so you just have to run it. And then just click this schematic capture. So to see if there's already a library, just click this letter P So as you can see, there is already a library for this application, but if there is no library, you can proceed here in program files. Just click here and then find this folder, Lab Center Electronics, then click it, and then right click this folder, and then properties, then go to security. So click edit, just click this full control, modify, and then apply. Yan. Then let's refresh. Then if there's still no libraries, found, just click this Proteus app, right click, and then click the properties, and then go to compatibility, and then check this run this program in compatibility mode, and then run this program as an administrator, and then click apply and OK. Then refresh again and open the file, open the application, and then check again if there's already a library. So as you can see, there is already a library here. So that's all for installing and downloading a Proteus version 8.10.
And now, since we are done with the installation of Proteus, we will now proceed now with the opening of the program. So here is how it looks like. This is the IDE of the Proteus version 8.10. So this is the new project, and then we can also see this as the schematic capture, which we can directly create a layout, and then we can also open a project as well, and then we can also open a project here, since we have a tab here, and then we also have here in the start, we can open a project, create a new project, open sample, and let's try to create a new project. And let's wait, let's rename the project. We will name it as test, and then we can also change the path or the location of our file of our Proteus simulation, and we will click next. Let's replace the existing project since test has been already created earlier for our test, and let's click next, and then let's click finish. And here it is. Here is the layout of the Proteus. Here is a new project. We can also create a new project, open a new project, save a new project, and then home page. And then here's the file tab, edit tab, the view tab, the tool tab, the design tab, and here it is the graph tab, debug, library, then template, and system, and here's the help tab. And so we can create a new project by clicking our library, and here are the broad list of our components. So we can scroll down here to see all the components that we can utilize for our schematic. And let's remove this one. We will also can use this click this P, wherein we can directly search our components by the keywords. And since we are going to create a series and parallel circuits, we will be needing some a source, ground, and resistors as well as the LED. So let's try to look first at the source or the voltage source that we can utilize. So here are the list, no? By clicking the name of the component, it will also show or give the preview of the component. So in the right side, we can see the schematic symbol of the component. So let's click OK. And then we will be also needing another component, which is the LED, and we will choose the yellow color since it is our choice. And as you can see, as we click the component, the symbol is shown on the right side. Then let's click OK and click again the letter P icon, and we need some resistor, and we can alter the values of the resistance inside the resistor, but we will choose the resistor which has a 1 kilo ohms, and we will click OK, and then that's it though, I guess. So we can now create a new circuit by clicking the V source, and then dragging, then double click. Then you will see that the component has been seen on the layout, and then click again to place the component. As you can see, I had already clicked twice for us to establish the component on the layout or the schematic capture. And we will be also needing the resistor, and we can drag this one, click, and then click again. And then the LED, we will be also needing this one, click, and then click again for us to establish this one. And we will just arrange the positioning of the components for us to be more organized on this series circuit. And again, we will be needing more resistors that are connected in one path or in line with end to end, since a series connection is connected end to end. So we will just try to create a circuit that has been connected all the components to each other. So we will be also needing ground, in which we can press the right click on the schematic, and then click the place, and then find the terminal, and then find the ground, and then click the ground, and we can place the ground here. And then that's it. We can now connect our components for us to create the series circuit. So let me just connect all the points. And now we are done with the connection. We can now alter the values of the components, changing their voltage content and as well as the resistance. So for the voltage source, we will alter the value to from 1 volt to 5 volts. And then the resistors, each resistors, we will try to change the values from 1 kilo ohm to 0.15 kilo ohms or 150 ohms if we had to convert it into ohms. And then let's copy this one, then click OK, then paste the text that we had copied, and then OK. And then for the last one, we will paste again the value, and then let's click OK, and that's it, I guess. We can now run this. We can now I forgot, we can also add some text wherein which we can label this circuit. Let's find the marker on the left side, and then let's try to add some names on the circuit, which is the series circuit. Then we can alter the height or the size of the text here by changing the values. And then here it is. Here is the text, and then we can go back to our components list by clicking or open the libraries, and then we can drag now the text and then place it near to our circuit. And I guess that's it. We can now proceed to the debug So to the debug, we will click the debug on the debug tab on the top left of the IDE. Click the debug, and then we can now proceed to the run simulation, or pressing F12 will do. And now, as you can see, as we click the run simulation, our LED has been lighted up, which emits color yellow. This means that our series circuit is working perfectly, and this is how we generate a series circuit in the Proteus version 8.10. And now we can stop the simulation by clicking again to the debug mode and then stop the simulation, and that's it. And now, since we are done with the creation of our series circuit, we will now proceed to the creation of our parallel circuit. And parallel circuit is the composed, or it is comprised of branches in which the current is divided, and only part of those current is flowing through each branches. So we will now proceed to the creation of our parallel circuits, and we will also be needing this component still, since it is needed for the creation of our circuit. Let's zoom this out and zoom this in, and then click the V source. We will need this one, and then double click, and then we will be also needing the LEDs, and at least we should put at least 3 or 4 LEDs for us to visualize and see the parallel circuit and how the current is flowing through each resistor. And we will be also needing the resistors. Let's place at least 4, since we had placed 4 LEDs. And then we will be also needing the ground, and then we will right click place, and then click the terminal, and then click the ground, and that's it. We get double click this one to place the ground. And then we could also, to return to our original components, we could click the place again, and then the component, and then click at least one of our components, and then let's try to escape. Click the escape button for us to return to our components. And then, since we are done with the components, we will try to connect the wires, or connect them all, for us to establish a connection between each components. So let me just try to connect them all. And now, since we are done with the connection of our components, so let's change the value of the voltage from 1 volts to 5 volts. Then let's click OK. Then we will also change the value of each resistors from 1 kilo ohms to 0.15 kilo ohms, or if we convert it to ohms, it is just 150 ohms. So let's try to change the values. We could also click the text of the value for us to be directed to the changing of the values. Then click paste the value, and that's it, I guess. And we can now proceed to addition of our label, in which we will find it on this icon, and then we will click the marker, and then we can now click to the schematic. Then let's type in parallel circuits, and we don't need to change, it is already fixed. Then click, and then let's try to go back to our components, then escape, and then drag this one again. And I guess that's it. We can now proceed to our simulation, or let's click the debug tab, and then we can proceed to the run simulation, or we can also press the F12. And as you can see, as I press the run simulation, the LEDs is lighting up. It emits a yellow light, since it is a LED yellow component. and we are successful, no, and we had established a parallel circuits that has been very simple, no, in our Proteus version 8.10. And to zoom it out, here's our series and parallel circuits simultaneously on the simulation mode, and they are successful for their simulation. We are successful for establishing these connections, and I guess that's it. That's all for the simple components and circuit constructions of series and parallel connection in Proteus version 8.10. And we can now proceed to saving of our project. We can save this project, save as, and then we can rename this as test success, since we had successfully established this connection. And then we can also change the path of our file where it can be saved. Let's click save, I guess, and that's it. That's all for today. That's all for the Proteus version 8.10.